All right. Number whatever it is. How is it not on here? There we go. All right. Number 8. So what is the photoelectric effect? Explain the photoelectric effect. So here's the effect. When light shines on a metal, sometimes electrons are discharged, causing a current. The key word is sometimes. It does not always happen. It only happens sometimes. And that is what makes this interesting, is it should happen all the time. And it doesn't. It only happens for certain light.
So when light shines on a metal?
Yep. Sometimes electrons are discharged, causing a current.
Do you lose your water bottle?
Huh? No, I just keep forgetting it at home. So I've been using this guy. It's my least disgusting beaker.
I understand.
All right. So first of all, you all already know the photoelectric effect because you all know what solar power is. So, all right. Other than that, so solar power is literally the photoelectric effect. So if you're wondering how do you make electricity from the sun shines light on metal. The photoelectric effect happens because the sun produces all light. So it's not just the light that doesn't work, it's the light that does work also. And so it causes the photoelectric effect to happen, and that releases electricity. The reason it's clean energy is because the electrons just come apparently from magic, but they're really coming off of these metals. Okay? All right, so that's the photoelectric effect. All right, next one here, number 9. Explain the problem wave theory had explaining the photoelectric effect. Okay, so according to wave theory, again, I apologize, there are many words. That's why we're only doing this chunks at a time. So according to wave theory, this should happen for any frequency as long as the light is bright enough, but it only works for some frequencies, no matter how bright it is. Okay? So if you take red light and you shine it on whatever the target was, I think it was sodium. If you shine red light on sodium, it does not matter how big and how bright that red light is. It's not going to do it ever. But you can have a really dim ultraviolet light and it will work. Or violet and it will work. And that was really bizarre. Because energy comes from amplitude, how bright the light is.
Why is that?
So, think about an ocean wave. Which kind of ocean waves have the most energy? The biggest ones, right? So that was what we thought about light too, because we knew light acts like a wave. And I want to make sure to point this out. It's not that we were wrong about light, and it's not a wave, it's a particle. We were right about light, it is a wave, but it turns out it's not only a wave. It's also this particle thing too. So we thought that the energy came from the wavelength, or sorry, energy came from how big the wave was, how bright it was, but it actually comes from the frequency.
No, right, yeah, but like, is there a specific reason to why it does that?
Yes. We'll get there, I think. Otherwise, I'll explain it. But yeah, there is a reason. Okay. How quantum theory answers this question. So each frequency has a specific energy, and those energies correspond to the frequencies of light. And then, Josh, I'll get to your question here in a second because it goes with this. So each frequency has a very specific energy. Those energies correspond to the frequencies of light. Okay? So red light has a lower energy than violet light does. And so therefore, the amount of energy required to make that photoelectric effect happen for sodium is the amount of energy that violet has, not the amount of energy that red has. So red doesn't have enough energy. Likewise, something like gamma rays have too much energy and also wouldn't work. You have to have the right amount of energy. So the question is, how do I know how much energy I need to have? This isn't on here. This is what Joss was asking. Here's how we know. Remember I talked about there's certain energy levels and that the electrons jump between them? That amount of energy is what light works. So if it gives off blue light, then blue light will do the photoelectric effect. There we go. I'll let you finish those up. So it depends on what the element is. All right, number 11. What are the two natures of light, and what is this principle called? So the two natures are wave and particle, and it's called wave-particle duality. Basically, it means it's a wave and a particle at the same time, which is weird, but that's what it is. So, what is a photon? A photon is a light particle. It's often called a wave packet. It's basically a single wavelength of light that acts like a particle. So a photon is the name of the light particle. So if light acts like a particle, there has to be a name for these little light marbles. I think that's why I think of them as light marbles. So there has to be a name for that. And what's the name? It's called a photon. Okay, so next time you want to sound smart, start talking about photons to people, because it sounds really smart, and it's not that hard of a concept once you understand it, which is light acts like a wave, and it acts like a particle. We call the particles photons.
No, you talk about that when more people walk away from you.
I mean, yeah, that's also a helpful skill to have. Next time you have a person by you don't like, they're like, hey, you want to talk about wave-particle duality?
I thought photons was like what the flowers take in.
No, I'm not being funny. That's photosynthesis.
I mean,
never mind.
No, but to be fair, they are taking in photons, because photons are those light particles, and the light particles are what hit the leaves. And yeah.
There's a reason photon.
I knew that.
Photon is the
I knew that.
It's cool.
This is how you get people away from you. You say, like, oh yeah, I know photon synthesis.
Yeah. Wave particle duality.
Isn't that cool though?
What?
Like how flowers just take in like light.
Well, think about this. What if we could make power plants that did that? What if we had power plants that took sunlight and turned it into energy?
We do that.
No. We have solar panels. Yeah. But like, I'm thinking about like, what if you could do what plants do? What if you could paint your skin green and it would do photosynthesis for you?
You know what's cool? Have you seen how a dandelion grows? Oh my goodness.
All right. Does anyone have any questions? So we're going to stop here for the notes.